Good morning. Welcome to Chemical World. Today we discuss about Chapter 7, Combustion, Fuels and Flame. So in this chapter we separately discuss about the information about combustion and fuels and about flames also. Now if you see the different types of fuels available in different areas, especially if you go to village side, what you get different types of fuels in rural areas. You will get wood, coal, cakes of cow dung. So these are available and cheaper and safer for the people in the rural area where they use for cooking purposes. Not only for cooking, but anything which they want to do by heating process, they use these three materials. But if you come to the urban side, city side, town side, if you see, we are using the fuel called LPG, liquid petroleum gas, as a fuel using for cooking purposes and so many other applications also. Now here my question is that if you want to get heat from any material, is it required to burn them? Do you have to burn the coal to get heat? Do you have to burn the cow dung to get heat? Do the gas has to burn to get heat? Why it has to burn? Why they have to burn? Why the combustion process demands the materials to be burned? See here, use the word combustion. Soon I will tell you what is combustion means. Now, if you take the other two examples like candle versus coal. If you burn the candle, if you lighten the candle, not burn, lighten the candle, you get the flame and the wick of a candle. But if you burn the coal, you're not getting flame. Why? In both the cases, you're doing burning process. Burning of wick here in the candle and burning of the coal there. But here we are getting flame. Here there is no flame. Why? What is the difference between them? So to understand these questions and to answer all these questions, we have to learn all the concepts in this chapter. Now why don't you wait? Let us start to discuss about the combustion process. Okay, do all materials burn? The question itself asking you that whether all the materials burns to get heat, whether they burn, are they burning in the same fashion or they are burning in different fashions? To understand this, let us do a small activity. So take a spirit lamp, you can take candle also, a spirit lamp. Now use the tongs, this is called tongs. Using tongs, keep the substance near to the spirit lamp. It is substance, I can say material, near to the spirit lamp. Now the caution is that you have to touch carefully to the tongs here. Don't touch at the starting point or starting stage of the tongs. It may burn your fingers. So keep the fingers away from the starting point of the tongs so that you can touch the edge side of the tongs. You hold the tongs with your fingers and keep the material near to the spirit lamp and observe what happens. First of all, you take the material called coal and observe whether it is burning or not. Now next, paper. Next, wood. Next, plastic. Next, cotton cloth. Next, nylon cloth. So like you take available materials what you have. Now if you check each and every one in this activity, you observe that each and every material burn, but some material burns very quickly, some material burns slowly, some material as soon as burns they will show flame, some material doesn't show flame. All these variations because of their chemical properties. We understand that yes, all the substances have to burn to get heated. Okay, but some are burning very quickly, some are burning slowly. Now what about liquids? Liquids, they are able to burn. To test, again do a small activity. Take a container. Inside the container you fill the liquid. Suppose the first liquid is water. Take water. Bring a matchstick which is stuck with the surface of the matchbox, or I can say lighten the matchstick and bring the matchstick near to this liquid. Keep it for some time and observe what is happening, whether liquid is burning or not. Now this, replace the water with kerosene, petrol, diesel, coconut oil, mustard oil, etc. Now what your observation? Your observation is that some liquids burns quickly within a fraction of a second. As soon as you keep the matchstick near to the liquid, burns. Some liquids, they takes time. Some liquid doesn't burn with a simple amount of heat. So this demonstration conclude you that different liquids have different burning stages. So we understand that if you want to produce heat, each and every substance should be burned. It may be either it may be solid or it may be liquid. It should be burned. Now that burning process is what called combustion. But actually, what is the actual definition of combustion? So combustion is a chemical reaction. A chemical reaction in which materials or material interacts with oxygen in air to generate heat is what called combustion. Read the statement once again. It's a chemical reaction. So what happens? All these materials interact with the oxygen in the air to generate heat. So in the burning process, the same thing happens. So burning is a normal word we are saying, but technically the burning is called combustion. The statement clearly mentioning you that without oxygen, combustion process is difficult to happen. Or you can simply say that impossible. Oxygen is required for the combustion process. So the materials which are favorable for burning or favorable for combustion, those materials called combustible materials. So they are favor for combustion process. The materials which are not favorable are called non-combustibles. So combustible material. In a previous example, if you see, the paper easily burns, wax easily burns, coal easily burns, plastic doesn't easily burn, rubber doesn't easily burn. So plastic, rubber, non-combustible, wood, coal, wax, all these examples for combustible materials. In the combustion process, earlier we discussed that oxygen is very important. Then how do you test? Here I will give you two activities. I'll demonstrate you two activities to tell you that oxygen is very much required for the combustion process. Number one, a simple one. So you take a candle and lighten the candle using a matchstick. So when you lighten the candle gives flame. It's a flame. So you can keep on seeing the flame for a long time till the wax exist. Now when the flame is coming in the candle, take a glass tumbler and keep the glass tumbler upside down on the candle like this. Upside down the candle. Now observe careful what happens. So if you see, slowly the flame gets down, and after some time the flame goes off. There is no flame. There is no light inside. It stops. Why? Because when you keep this glass tumbler upside down over the candle, there is no possibility of air passing inside the tumbler. Because there is no air inside, there is no oxygen. When there is no oxygen, slowly the flame goes off. So this demonstration explains that oxygen is required for combustion. That's the second activity. Second activity, what you do, take a spirit lamp. You could take candle also. A spirit lamp, take spirit lamp, this is the flame. It's a test tube. Okay. Now, inside the test tube, place some potassium permanganate KMnO4 crystals inside the test tube. Potassium permanganate KMnO4 crystals inside the test tube. Before keeping the test tube near the flame, you have to do another one action. What is that? Take an agarbatti and burn the agarbatti, and you'll get some flame, some smoke from the agarbatti, not flame, smoke. When you're getting smoke, immediately you please off the smoke, put off the smoke and put off the burning everything and keep it aside. Now take the test, test tube, fill it with the potassium permanganate crystals and keep near to the flame of the spirit lamp. Now what happens? When the potassium permanganate crystal starts burning, when they starts burning, they changes like this. 2 KMnO4 gives rise to K2MnO4 plus MnO2 plus oxygen. So gas. It releases oxygen gas here. So earlier, what is the agarbatti you have? Agarbatti stick. Bring the agarbatti stick and keep inside the test tube like this. Inside the test tube, what happens? Again the agarbatti stick starts burning. Again the agarbatti shows the flame. Why? Because the presence of oxygen. So this also proves you that oxygen is important for combustion process. So for combustion process, the important factor, another important factor is ignition temperature. Ignition temperature which ignites the burning process. Then the burning process continues. Different metals have different ignition temperatures. Some metals have very high temperature where the metal starts burning. Some metals have very less temperature where immediately they starts burning. So for example, if you see a simple activity I am going to tell you. Take a magnifying glass, keep a paper on the ground, under the sun, and keep the magnifying glass over the paper for some time. Then what happens? After keeping the paper some time, then you touch the paper, you feel that at that point, at that location of the paper, it's very hot. I mean, the sun rays falling on the magnifying glass or magnifying lens and those sun rays are concentrated on the particular point on the paper, so that they increasing the temperature of the part of the paper. Now, if you want to know what are the igniting temperatures of different substances, you can do small activity. Check the paper, wood, coal, wax, etc., the solid substances, and burn them, and see in which case the burning is quicker, in which case the burning is slower. Generally, if you burn the paper burns very fast because its ignition temperature is very less. But if you want to burn the coal, it takes time. Immediately won't burn because its ignition temperature is relatively greater than the paper. Now, if you consider the liquids, do the same testing of ignition temperature with liquids. You take LPG, it's not liquid, it's liquid petroleum gas. Take petrol, take diesel, take kerosene, take coconut oil, and test. How do you test? Take a tumbler and fill the tumbler with these liquids one by one, and lighten a matchstick and bring that lightened matchstick near to the liquid and see whether it is burning or not. Some liquids burns very fast, some liquid takes time. Suppose if you take petrol, keeping the matchstick near the petrol, immediately it burns. Diesel burns, LPG gas burns. So that activity tells you that their igniting temperature is very, very less. That's why LPG, petrol, diesel actually called inflammables. Inflammable or inflammable materials. Why they are called inflammable things? Because they burns quickly at less temperature. If you are seeing any tankers carrying the LPG or the petrol, diesel on the road using a truck, so on the tanker written, the back of the tanker written that inflammable substances, keep the distance, because it can be a caution that they may burn with very less temperature, that will be harmful, disaster may happen. So that's why you have to keep distance. So we understand about combustion. We also understand that for combustion, two things are important. One is oxygen in the air, second thing is ignition temperature. Now, this combustion mainly two types. One is spontaneous combustion. The second one is rapid combustion. Spontaneous combustion means the material starts burning and catch the fire, is what called spontaneous combustion, without any extra effort. So the material starts burning and catch the fire without extra effort is called spontaneous combustion. Like matchstick. When you struck the matchstick on the surface of the matchbox, then in few seconds it burns and catch the fire and shows the flame to you. Spontaneous combustion. Rapid combustion is very much faster than spontaneous. Rapid combustion is light and heat both. Rapid combustion, the ignition temperature is very, very less and combustion is very, very rapid. For example, gas. If gas is filled inside the room, then the gas catch the fire with a simple spark of light. Simple spark. If anyone in the room stuck the matchstick, the gas is filled with the room is filled with the gas catch the fire. And that's very dangerous incidents happening in the different houses, especially in the kitchens. That's why the LPG dealers, LPG suppliers always tells you that whenever the cooking process happened in the kitchen, please switch off the regulator. If you don't switch off the regulator, the gas may leak and they fill into the room, and with a small spark it starts burning. So that is what rapid combustion. So spontaneous combustion means the material burns and catches the fire immediately. Rapid is very fast. Here also materials burns, catch the fire with immediate action and with small sparks. Now coming to this matchstick. So every day in life, if you want to get any fire or flame, we use matchsticks only. Very available items to us. So if you take the matchstick, the head of the matchstick, the material what is placed in the head of the matchstick is made up of different chemicals. Antimony trisulfate, potassium chloride, white phosphorus, and glue plus starch. Whenever the matchstick is stuck on the surface of the matchbox, I told earlier, combustion has to be happen, but to happen combustion, ignition temperature should be less. Then the combustion will be done very fast. So this ignition temperature developed because of white phosphorus. When you stuck the matchstick on the surface of the matchbox, this white phosphorus immediately gets the burning stage and increase the ignition temperature, and immediately this antimony trisulfate, potassium chloride starts burning, and then you can see that matchstick is burning and giving flame. But later they have understand that white phosphorus is very dangerous to the people who are making matchsticks, because white phosphorus is very sensitive to the oxygen, to the air. If it starts burning, it burns whole the area where they're making the matchsticks. So later there's a modification done in the matchsticks. So they removed the white phosphorus on the matchstick, but they kept red phosphorus on the surface of the matchbox. So when you stuck the matchstick on the surface of the matchbox, on the surface of the matchbox, the red phosphorus gets heated, ignite the temperature, and within course of time, in few seconds, these two chemicals burns and matchstick starts burning and gives flame to you. So in that way, they have protected the many number of people who are making the matchsticks. All this combustion process we are discussing only because we have to know about the fuels. Without fuel, today I can tell you that nothing is possible. Without fuel, you can't do cooking. Without fuel, the vehicles cannot start. Without fuel, machinery parts can't work. So we're all depends upon the fuel. Fuel is the major source for doing anything on the planet Earth. So these fuels mainly classified into two types. One is fossil fuels. The second one is non-fossil fuels. Fossil fuels. What is the fossil fuel? Fossil fuels are nothing but the amount of fuel what you are finding in the nature is less comparing to the consumption of the fuel. In other words, the consumption is more comparing to the product of the fuel, and all this fuel have to be burned to get the fire, to get the heat. So fossil fuels examples: coal should be burned, wood should be burned. Next, coal, wood, and petroleum products, petrol, diesel, everything. So these are fossil fuels which have to be burned to get heat, and from the heat we can get the fuel, and we can do all other purposes like cooking purposes or motion of a vehicle or the movement of machinery parts. The problem with the fossil fuels is that they are not eco-friendly. They create huge amount of greenhouse gases and pollute the environment. But the advantage is that their energy density is more. Energy density means they produce huge amount of energy by burning a small amount of material. So as the energy density is more, as the efficiency of these fuels are more, even though they are not eco-friendly, still today we are depending on fossil fuels. But scientists are curious, are visionary, and they have visionary mind. So they wanted to create some new type of fuels which are eco-friendly and which can have more product than consumption. And they have found, and those fuels are called non-fossil fuels. These non-fossil fuels are also called renewable energy sources. And renewable energy, the first one is, you know, that solar energy, sun. Solar energy. The sun is producing huge amount of solar energy, but the consumption what we are using is very less. Next, wind energy. Generally, if you see in different locations of India, you have wind turbines. The windmills, we say. The windmills actually placed on the top of the hills because you get huge amount of air. Because of air, the wings or the blades of the mill fan rotate, because that electricity is produced. Next, oceanic energy. This is another creative type of energy production where if you go to the oceans, if you stand at the beach of the oceans or the seas, you'll see the tides. Because of the movement of the tides, they are producing the electricity. It's very friendly. Of course, installation is very expensive, but once installed the power plant, you can get huge amount of electricity, which is 100% eco-friendly. So these are different types of fuels we're using. Of course, we're using LPG, liquid petroleum gas, and CNG, compressed natural gas. LPG is also very much famous, liquid petroleum. And CNG also very famous, compressed natural gas. Compressed natural gas is eco-friendly. LPG gas, I can't say 100% eco-friendly like non-fossil fuels, but it is better comparing to these fuels. So in modern world, we are thinking to produce the fuels which are eco-friendly and which are more efficient. But till today, we are successful to produce eco-friendly. But coming to the efficiency is still more in fossil fuels than non-fossil fuels. Now, how much of energy a fuel can be produced? How can you measure? It is measured using caloric value. By caloric value. What is meant by caloric value? It's very simple. Calorie is a unit of energy. How joule is a unit of energy, calorie is also a unit of energy. So calorific value is nothing but the amount of heat energy produced by burning 1 kg of mass. Okay, I will write here. Amount of heat energy produced by burning 1 kg of mass. So this calorific value or calorific value tells you that how much of heat energy producing. Based on that, you can tell that which are more efficient, which are not relatively efficient materials. So the calorific value or caloric value, both are same. Always expressed in terms of kilojoules per kg. So 1 kg, how many kilojoules of energy is produced? That is what kilojoule per kg means. So if you observe this table, the cow dung gives from 6,000 to 8,000 kilojoules per kg. Wood, 17,000 to 22,000. So wood is more efficient than cow dung. If you go through the table, you can understand that petrol is 45,000, LPG is 55,000. See here increased. Hydrogen 1,50,000. So hydrogen gas itself gives huge amount of energy by burning 1 kg of it. So in that way, you can find their efficiencies by knowing their calorifical values. In the forest, many times you heard that forest caught fire. All the trees are burned because of fire. Why it happens? It happens because of a small reason behind that. Because of high temperature in summertime, the dry leaves catch fire because of high temperature. When they catch fire, soon that fire carried to the trees. Then soon all the trees catch the fire and all the forest catch fire. And it is very difficult to stop that fire. Many times they given many examples to us in the history of world where many forests are caught fire because of high temperature of sun. Okay, now coming to our daily routine works. Suppose if a house catch fire, if a company burning because of fire, or if any industry catch fire, how could you stop the firing? You heard that the fire engines are coming, the firemen come and they try to stop the fire. How they try to stop the fire? And today it is very important to any organization, even to schools also, that each and every person should know that how to stop a fire and what are the materials to be used to stop the fire. So the main factors behind to catch a fire is combustion materials. Combustion material. If that material is so favorable to the fire, then the material should be stopped, should be moved away from the place. Now second, ignition temperature. I had told you earlier in the class, ignition temperature is essential for the combustion process. So that ignition temperature should be increased. If it is less, huge amount of fire will come. If it is increased, so fire can be minimized. So combustion material, ignition temperature. Third is very important one, oxygen in the air. So fire keep on increases, the fire intensity keep on increases because of oxygen. So if you want to stop the fire, you have to remove this combustion material from the location. You have to increase the ignition temperature. You have to reduce the oxygen in the air in that particular area. So how do you do? Generally the important and the easy source to stop the fire is water. We use water as fire extinguisher to stop the fire. But water can stop the fire to particular substances only, like wood and paper. But suppose think that a house caught fire because of electrical appliances, caught fire because of main supply. And water is very dangerous because already it is short circuited and caught fire because of electricity, and if you pour the water on the house, as it is short circuited, the current passes through the water and it will give electric shocks to the firemen. Now if a building caught fire because of oil, generally some oil plants caught fire, then you can't stop that firing of oil plants using water. Difficult. Now what is the second alternative? The second alternative, the best alternative is carbon dioxide. Carbon dioxide is the best to stop the fire. All fire extinguishers have carbon dioxide. This carbon dioxide works like a blanket. Suppose a house is burning, the catch fire started burning, then this carbon dioxide creates a blanket to the house so that it increases the ignition temperature, it reduces the oxygen in the air, so that quickly we can get the control of the fire and we can stop the fire. That's why I'm suggesting, everybody suggesting that have fire extinguishers of carbon dioxide each and every organization and school to protect from firing.